Calculate the enthalpy of the following chemical reaction. 1 mole of carbon disulfide liquid is added to 3 moles of oxygen gas. The products of this reaction are 1 mole of carbon dioxide gas and 2 moles of sulfur dioxide gas. Given, 1 mole of carbon solid is added to 1 mole of oxygen. The product of this reaction is 1 mole of carbon dioxide gas. The heat of reaction, also known as enthalpy of the reaction, is equal negative 393.5 kilojoules per mole. 1 mole of sulfur solid is added to 1 mole of oxygen gas. The product of this reaction is 1 mole of sulfur dioxide gas. The heat of reaction is equal negative 296.8 kilojoules per mole. 1 mole of carbon solid is added to 2 moles of sulfur solid. The product of this reaction is carbon disulfide liquid. The heat of reaction is equal positive 87.9 kilojoules per mole. Step 1. What to do to the data equations. Leave the first equation untouched. CO2 is the product in the main equation. The first equation, 1 mole of carbon solid is added to 1 mole of oxygen. The product of this reaction is 1 mole of carbon dioxide gas. The heat of reaction, also known as enthalpy, is equal negative 393.5 kilojoules per mole. Multiply the second equation by a factor of 2. 2SO2 is the product as well. The second equation, 1 mole of sulfur solid is added to 1 mole of oxygen gas. The product of this reaction is 1 mole of sulfur dioxide gas. This second equation is multiplied by a factor of 2. The new value of the heat of reaction after the multiplication by factor of 2 will equal negative 593.6 kilojoules per mole. Flip the third equation. CS2 is the reactant in the main equation. The third equation is flipped, where the reactants will be the products, and the products will be the reactants. The flipped third equation is now 1 mole of carbon disulfide liquid is decomposed to give the products of 1 mole of carbon solid and 2 moles of sulfur solid. Step 2. The final result is determined by adding the 3 equations, the first, the second, and the third, with their adjusted corresponding enthalpies. The first equation is kept as is. The second equation is multiplied by a factor 2. The third equation is flipped, and the sign of the heat of reaction will be negative. C's and 2S's will be cancelled from the final total equation because both these elements appear at reactants as well as products sides of the final total equation. The 1 mole of carbon solids and the 2 moles of sulfur solid will be cancelled from the final total equation because both of these solid elements appear at reactants, as well as products sides of the final total equation. The final total equation has 1 mole of carbon disulfide liquid and 3 moles of oxygen gas as reactants and 1 mole carbon dioxide gas and 2 moles sulfur dioxide gas as products. The final total enthalpy is calculated by adding the heat of reaction of the three adjusted equations mentioned above. Negative 393.5 kilojoules per mole plus negative 593.6 kilojoules per mole plus negative 87.9 kilojoules per mole. The final total enthalpy is negative 1075.0 kilojoules per mole.